So something to think about when trying to decide, do I deprotonate versus an addition step? So the hardest one to kind of figure this out with is the strong base hydroxide, NaOH. A lot of times it's NaOH. And the problem is this can be a base, and it can also add into carbonyls. So depending on your type of carbonyl, that's what you need to look for. So if it's an aldehyde, or when it's a ketone and an aldehyde, the addition step, while that can happen, there is no good leaving group. So it's not as likely. Or it will happen, but usually what's more likely is you're going to deprotonate the alpha CH. If you see an ester or an anhydride or an ester, what's going to happen with this? These are going to turn into carboxylic acids. So addition is going to be more likely. Carboxylic acids. So there's a clear difference when you have something like this that's going to deprotonate ketones and aldehydes and turn, right? Acid chloride would be another one, and acid chloride would also turn into a carboxylic acid. Right? Now some trickier ones, when we're trying to think about deprotonation versus addition. What if I did this ester and I reacted it with this base? So now remember we talked about matching the ester with the base. So even if this reacts and does addition, you're going to get back the same ester, right? So then it's going to be about the deprotonation. Then it's going to be about the deprotonation. Another thing you can do to make sure, if you want to make sure you do deprotonation, instead of having a small base, use some of those bulky bases. One of those bulky bases is lithium diisopropylamine, that LDA. Use a bulky base, right? That'll usually prevent addition because it's too sterically bulky, and it'll do more deprotonation of the alpha CH.